I'm going to tell you something about graphene. And for the people who do not know graphene, it was discovered in 2004. And the people who discovered graphene got the Nobel Prize in 2010 for this discovery. It's 200 times stronger than steel. It's a great electric conductor, and so on, and so on, and so on. So all over the world, people are searching for a way to make graphene on a large scale, because then they can make a lot of money. So I found an article about a lab in China that had developed a process by calcination of calcium carbonate with magnesium to create graphene. So they used an oven. The oven was filled with argon, and the oven was heated till 850 degrees. So at that point, the calcination started. So you can see that during the process in the oven at a temperature at 850 degrees, the calcination of calcium carbonate starts, and calcium oxides and CO2 exist. The CO2 will react with magnesium and form magnesium oxide and carbon monoxide. And the carbon monoxide will react with magnesium, and then carbon will show up. Carbon was examined, and it turned out to be graphene. So they have discovered a way to create graphene. So the chemistry behind this whole project is more or less similar to the curriculum that we have in our country for the school exams, chemistry. And the good thing was, I have all the chemicals in my classroom. The only problem that I had was I don't have an oven, which is filled with argon. So I had to find a way to create enough heat for this calcination. So I thought of using an excess of magnesium, because when you burn magnesium, the temperature can rise till 2200 degrees. That should be enough for this calcination reaction. So I tried that, and it turned out it worked. So I have created a school experiment, which I can demonstrate in my classroom, and I can demonstrate the principle behind this experiment from China. For me, this is very important to announce, because I don't want to give the impression that I can make graphene with this experiment. I only can demonstrate the principles behind this process, because we all know that carbon can have different structures, and you have to have the right circumstances to create graphene. And in my classroom, I don't have those circumstances. So again, I'm not pretending to create graphene, I'm demonstrating the principles behind. So during my school experiment, I use calcium carbonate, and I use 1 spatula of calcium carbonate, put it in a porcelain dish, and then I use an excess of magnesium. So in this case, I will mix 2 spatula magnesium with my calcium carbonate, and I will make a mixture of it. And I will demonstrate this, I will show this mixture to my students, because they have to know, they have to see that the mixture is light gray. They have to know that, because we learn them if we have a chemical reaction, they change the, for instance, color or so, then we can see it's a chemical reaction. So they have to see the first starting material. So now there's enough heat for this calcination, and this is the process that takes place. And this is the result. And you can see there's a big difference between the starting materials and the materials after the reaction. I did bring a result. You can really see it's very dark. So there should be carbon in it. So during my lesson, I will ask my students to answer these questions. So they should be able to describe the starting and ending substance. They should be able to describe the reaction phenomena, explain which phase magnesium has in the oven, it's molten, explain why the oven is filled with argon that doesn't react with other chemicals. So they have to make the reaction equation correctly. They should recognize molecules, salts, and metals in these reactions. So now I have a new problem in my classroom with my students, because we have a mixture of 3 solid chemicals, and I want to separate the carbon from this mixture. And the question to you all is, how can I separate the carbon from this mixture? Oh, nice. Centrifuge would be interesting. I think it's I think there is a way that is easier than centrifugate. So I hope that my students will recognize calcium oxide and magnesium oxide as a base, like acid base. So I hope they will recognize it as a base, and then they should answer that I have to use an acid. And in this case, I will use hydrochloric acid, because when it reacts with the mixture, calcium oxide will react to calcium chloride, and the magnesium oxide will react to the magnesium chloride. Both are salts that are very good soluble in water, so they will solve into my mixture. So now it's an interesting thing, because there's also gas in this reaction. You can really see there's a lot of gas coming from. You saw that there was a gas, and I want to know if you can answer the question, which gas did appear? So we have a couple of options. I can't read. The first one is hydrogen. The second one is oxygen. The third one is carbon dioxide, and D will be helium. Thank you, David. Correct. B, okay. Thank you, Daniela. A. Thank you, Janet. Thank you, Lucy. A. Okay, very nice. Thank you very much for answering this this question. The thing is, when I have used an excess of magnesium, and the magnesium will react with the hydrochloric acid, hydrogen will be formed. If there still is calcium oxide in this mixture, because it didn't react or because I used an excess of it, carbon dioxide will be in this reaction. So 2 gases are possible: hydrogen gas or carbon dioxide will be another possibility. I have now a mixture of a solution from calcium chloride and magnesium chloride, and in the mixture is a solid carbon structure, and I have to separate this from this mixture. So the next question is, how do I separate it from my mixture? So you saw it already on the movie. Of course, we use filtration for this process. And after the filtration, this will be the result. So you can see a lot of black material in the filter, and this is carbon. So for me, this is a more or less simple experiment with a lot of chemistry in it, and that's why I'm very enthusiastic about this experiment. It's very good for the students to think with you as a teacher. You can ask the right questions, and then you can train the children in their chemistry. So for me, this is a very nice experiment. And I hope that you all also will be very enthusiastic about this experiment, and you will do it in your school also.